just look at the procedure, then we'll go forward from there. We are using soil gel. Good, very correct. Thank you, sir.
You're welcome.
Yes. So look at this. This is our precursor, as we said yesterday. This precursor is made up of whatever you want to use. Anyone, zinc, silver, these are your precursor. That is your mixture, your combination. Everything is there, which we are going to dissolve in your solution. You dissolve this one in your solution. It's a simple procedure you can use. You can even give to your student. They can perform it easily in the lab. So you dissolve it. So there are 3 procedures to it. You can either choose either of these 3 procedures. For soil gel auto combustion, we can use spin coating. Once you have your solution, you can use spin coating just to deposit on your. So spin coating, if you have that machine, very easy. You coat it on the slide. Then you can as well use what we call deep coating. You have your substrate. Once you have your solution, you can just dip it gently in it. It will deposit on the substrate. Then it depends on what you want to do. You know, this experiment, you may want to look at the effect of it on the material. Maybe you leave it for 1 day, bring it out, go and check. You may leave it for 2 days, 3 days. Then you look at effect of deposition on the material. It might be 2 days, 3 days. You take your record, a day, 2 days, 3 days, 4 days, 1 week on that deep coating. Then you can just take your record. By the time you try and characterize it for 1 day, what is the effect? Try it 2nd day, what is the effect? On the 3rd day, what is the effect? Definitely you will see some variations, which you can record at the same time. So that's about deep coating, very simple. Once you get your solution ready, you can perform what we call deep coating. Then the 3rd one is dry as a powder, and then you now calcinate. So you can completely dry it to form what we call auto combustion. It will combust to just dry completely. So these 3 processes are available, which you can easily do through soil gel method. Okay? Go to the next slide. Let's quickly round up. Okay? This is the auto combustion now, as I've described it. The auto combustion, you have your precursors, you dissolve in the solution. From there, it will form what we call a gel. We call sol and gel. Am I right? Your sol's colloid, in form of colloid. Then you put it on your magnetic stirrer, which is this one here. This is our sonicator. This is the magnetic stirrer, both heater and stirrer. This one perform the 2 functions. You can heat at the same time. You can use to stir. So that is the function here. You stir it to form your gel for you. The zero gel, when you have dry it, you will turn to zero gel. Then after that, dry, you calcinate it. We don't have the oven here. The oven is very big, so we can't ship it down. So you calcinate, then it will turn to powder. That powder, then you now, we have what we call a small pestle and mortar, which you can use to turn it to powder. And that's what we have here. You press it. You can either use the powder for the characterization, or you can pelletize it. It's very good if you pelletize it. So most machines, they can use the pellets. So if you pelletize it, we have a pelletizer. I think we have it in our lab. A pelletizer, you just put the particle, then you press it high pressure. It will turn to like paracetamol. That's paracetamol. That small shape. So you can easily use it for characterization. So it will be in this form. If you pelletize it, you have this. Then the supreme final product, then these are the various characterizations you want to use. This is SRD, this is SEM, UV, TEM. Once you have the pelletized sample, you can send it for all the various characterization. Okay? So these are the stages involved in soil gel auto combustion. Follow this procedure down, down, down. Very easy process. Go to the next slide. Okay, let's look at this, this soil gel. I think it has a precursor there. There's a video there. Can you click on that? The play. There's a play there. Do you see it? Click on it again. Click on it again. Okay, go up. Is it showing any? Go up. Here. There should be a play there. Do you see any play there? It's not showing. Click on it. Okay, it's taking you back. Okay. It's a video. I really want us to show you. Just demonstrate how the whole process will just go from beginning to the end. It's a short video. Maybe I'll look at it later. I'll play it so that we can look at it. So go to the next slide. Next slide. Okay, this is hydrothermal method. We are not going to do this one here because it involves oven. We're going to use oven. So this is the autoclave. We are going to use autoclave. This is the Teflon. We are going to load your sample. So it's also follow the same procedure. Once you have your precursor, you have mixed your precursor. Then you load it into the autoclave. The Teflon, cover it, put it in the autoclave, then set it in the oven. The mixture from here to your Teflon here. In Teflon, there are ranges. It's advisable that you take precaution because this thing can actually blow. It can actually destroy your oven. We witnessed one in NCP. It actually blew up the oven. The guy put the autoclave in the oven overnight. Because there's light and you can easily run it overnight like that. At times you want to run like 12 hours. 12 hours in the oven. 12 hours, 15 hours in the oven. And at around sometimes 800 degree or 760. So if you want to run it in the autoclave in the oven, there must be stability of light. That's one challenge for this experiment. It's very accurate experiment, very good. It can give you very nice material. It's hydrothermal method, very good. So autoclaves has a different dimension. We have 50 mil, we have 100 mil, we have 150 mil. So it's always advisable if you are preparing for 50 mil. So don't fill it up to the brim. You prepare 2/3 of your volume. If it's 50 mil, so prepare 2/3 solution to put. Are you getting my point now? So if it's 50 mil, for instance, your Teflon is 50 mil. If this is 50 mil, so all you need to do, prepare. If this is half, let it not go beyond this place. Yes, are you getting it now? So prepare 2/3 of it. So if you fill it to the brim, because the likelihood of expansion will be there. And once it expands and there's no space for it to breathe, it will blow off. Okay? So prepare 2/3. Create a air gap here so that the liquid can breathe up. Or when steam is up, no, it's getting bubbling up, it will continue to push the lid. So that's just it. If it's 100 mil, prepare 2/3. If it's 150 mil, you prepare 2/3 of it. Just likewise, you can see it here now. The liquid stops somewhere here. So this is what you now load. You now put it in the autoclave. So you follow the procedure, solvent emission Teflon reactor, then put it in the autoclave. The same procedure. So you sit down from here to here. There will be a space. There must be a space. So we call it in situ growth. You can put it in the reactor. So put it in the oven. It will dry. Once it dry in autoclave, I don't know if anybody has autoclave in your lab. If you want to perform it. So once you've just followed literature, make sure you are following literature, standard article, that you follow their procedure. So once you set your time, maybe it's for 80 degrees for like 12 hours. Then you allow it to cool, natural cooling. If you bring it out, you want to force it open, you will spoil the Teflon. If you bring it out, you are now pouring water so that to fast track the cooling, it will damage the Teflon. So you allow it what we call natural cooling. Just bring it out, allow it to cool naturally until you have room temperature. In fact, it will be difficult for it to open safe if it's not to the room temperature something. So allow it to cool naturally. Then you can easily open the autoclave. And it's very strong. And when you want to put it, you cock it very well. Otherwise, it will blow off. Cock it very well. Then put it. Natural temperature will make it to loose easily. Then bring out your Teflon. You see the liquid. The solution will settle under. So you can use decantation. Just decant it. You see the residue under the something. Then you can now bring it out. You can wash it. Follow other procedures. Let me see the next slide. Okay, this is the green approach. That's another approach. We have soil gel autocombustion, hydrothermal method, then grain synthesis protocol. Grain synthesis involve raw materials like fruit, like leaf, and extract, bark of materials, which we can, it depends on what you want to do. You can turn it to powder, you can turn it to any forms of liquid solution. Just blend it. Most time they dry it. You dry it, and so if you dry this one now, can you see now? Turns to like this one, like curry powder or turmeric, or this something. So you can see what it turns to. So you dry it, you crush it, so it becomes something like this. Then you follow your literature. Depends on what gram do you want to measure. You measure the gram. You dissolve it, homogenize it in your distilled water, then put it on stirrer, stir it, heat, extract your liquid. So this is a process. You extract it through separation funnel. We're going to perform this. So all this one, you separate it from there. Through concentration, you decant it. You can store it. Then you can use it for the experiment. So this is green procedure. Very simple and direct procedure. Go to the next slide if you can. Yes, let's go back. So this is for another day. This is the characterization technique. So we'll stop here and do little things from here. So we're going to do little things from here. As I've said the other time, this is our heater and stirrer. This is distilled water, heater and stirrer. This is the sonicator. This is our digital scale. So this is a measuring cylinder. You need beaker, 100 ml. You also need 50 ml. This is the magnetic bar, different category, the long one. So you need it. So this is the arginate, which one of the surfactants we are going to use. Arginate is a biopolymer. We have chitosan. We have arginate. Then we are going to use, this is our sodium hydroxide pellet. We are going to use to precipitate the material. This is our the ferric we are going to use. No, it's zinc ferrite. It's a ferrite. So this is the ferric solution. This is the zinc. The zinc sulfate. So we're going to form a ferrite of it. Zinc ferrite. Okay, this is a combination. So we have all of them ready. So all we need to do is to start. If you look at the procedure, only that. Okay. I will say we print the procedure. Doc, do we? Okay, let me just follow the one I have. The procedure is already there. Maybe later, Dr. Lewis will print it so that everybody will have a copy. Step-by-step procedure. I've already prepared. We get it now? Sir? Yeah, I forwarded it in that experimental procedure. Experimental procedure, yes. Everything is there. Yes. So experimental procedure is there. So if we follow all the procedures are there. So maybe Dr. Lewis will forward it to the general platform. So you can access it from the general platform. So from there you will see experiment 1. Experiment 1. Then all Initially, I itemized it there. All the materials needed, you see down, down, down. Then the machine that we are going to be needed for this furnace, sterilizing oven, magnetic heater and stirrer, digital weight balance. We have digital weight balance. This magnetic heater and stirrer. So if you look at it, we have step 1. If you have it now, we have step 1. Step 1 is collection of materials for the sentences. Collection of material means you must first of all start with that. That's just step 1. What and what. Once you have your topic, okay, what do I need to perform the experiment? You collect your materials. So I will need to get this, I will need to get this, I will need to get this. Okay? So if I can get these 3, then this is the procedure, then I will need to get this. So I have this now, I have this, I have this, I have this. That's the first step. You collect your materials. And once you have all your materials ready, then you can now go to stage 2. Okay, check your group something. I learned that has been circulated. So that's step 1. Now, step 2 now. Sentences and surface encapsulation of the sample. So we are going to prepare our chitosan. Then, the arginate, we are going to prepare it. And step 3, we prepare the osmum gratissimum. We're going to prepare it. Then, step 3, we'll now prepare the zinc ferrite. We prepare the zinc ferrite. Then, solution. So what we are going to do, because of had it been that we have this one like 2 now, to make the work very fast, but with this one, we'll start with this one is an extract. Osmum gratissimum is an extract. This one is already made, but we need to prepare this. Osmum gratissimum is an extract. We are going to prepare it. So let's prepare it first. While we are decanting it or doing separation, then we're beginning to prepare the other one, so to make it ready for us to use, okay? So that one will be faster, the way I'm looking at it. So we'll start with that one. I think it's Saint Leaf. Yeah, he said the local name is Saint Leaf. Osmum gratissimum. Yeah, the common name. We also have Utazi. Utazi, Rugodema latifonium, is the Utazi. So she knows the procedure. She'll be helping me. So you have some precautions. You know, once you are working in the lab, you have to take your necessary precautions. Am I right? So you use your hand glove. You use your nose mask, because some of those things you have to be very careful. These are materials you have to get ready for everything you want to do, okay? Aganepa. Engineer, tell them that we have started our work. Tell them we have started our experiment. They should restore the light now. They should restore the light now. It's now that we want to start. Now that they now take the lights. Okay, it's common. Ah, okay. It will. Yeah. If that gen, we only power on this one, then we'll switch off the other gadget. I think it can power this one. Can power. How do you push this one? Come on, help us. Engineer. Okay. I can remove this one now. It's not useful again. Is this? Are you still using it? Is it still working? Is it working? I thought once there's no light, it's no longer work. Okay. Okay. So what you do? Let's extract that liquid first. This is our distilled water. So you always rinse everything with distilled water, so that everything. So yeah, distilled water. So we have sterilizing oven. Normally, when you rinse, you should be able to sterilize it in the oven. All the bakers put it in sterilizing oven. Once you have washed them, the sterilizing oven will sterilize it to be dry before you start using it. But we can't bring it down here now for this purpose. So we'll just improvise, okay? So this is the osmum gratissimum. It has passed through stages, okay? The first thing you need to do is to extract the fresh leaf, wash with distilled water. After washing, then you dry under room temperature, okay? You dry it. So under room temperature for 3 days until it's dry. Then you now turn it to powder. We have done that one here. It's already in powder form. So we need 10 gram to homogenize in 100 ml. 10 gram in 100 ml. So that's the first stage so that we can extract it. If you put the 10 gram in 100 ml. I think I saw one plug. This thing cannot enter here directly. There's one red plug the other time. I think, okay, it's there. Remove it from down. This edge will not enter. Okay. Let me remove this one so that it will not obstruct us. So that we can be seeing it directly. So it's reading to 0.00 as the scale. So I'll put my. It's ready now. I have to neutralize it back to 0 so that to turn to 0. Okay. Yeah. Off the fan. Off this one. I need 100 ml of this is exactly 100. It's 100 ml. So I need 10 gram. I can get my 10 gram from here. Let's do it twice. This is 5. So I'll draw another 5. So already 0 again. So I have another 5. Sir? Okay, good. It's 5.2, so we need 5, okay? So you have to reduce it. Exactly 5. So this will.
Because after this huge group will be arrest, they will do their own separately.
So we can now hit this one like around 30, 60 degree. So this is our magnetic stirrer. This is the bar. So we wash this one and we put it. So we can need something to plug this can come on. Okay, good. Yeah, good. So it's already power. So it's off. This is on. So we set the. This is the speed. So we can set the heat here. So we can increase the speed. We need like up to set up to 16. So this is so 60. Okay.
Revolutions per minute.
No. In terms of temperature.
Okay. 60.
Temperature. So this is the speed. You can, if we put the speed now, it will begin to move.
Set the temperature at 60, right? No, it's right. It will be raising.
Hmm.
Okay, yeah, that's the maximum.
Okay, you can be seeing it. Okay. No, this it varies anyway. Some, this is digitalized one. So some just have, you have to plug in and so this is the set. So just this is down, this is up. So you can just increase the temperature. Okay? So Yeah. So this is the speed for steering. That's what, I will set it to 60 to count. Yes. I think it's already warm now. So to continue, yes, the liquid content is so. So while this is going on, then we can do another one. We can do that for the next 40 minutes. Okay. So just time it. So the next thing we need to do is we are trying to prepare this one extract. This one is already made, this one is already made. But we need, even that we have another heater, we can be preparing that one, but we still need to come back to this heater for it to work. The light is really slow. It's not rolling the way I'm expecting it. The light is slow. Okay, let's make it like 200 mil to, yes. That maybe we can move faster. Turn is slow. It's smelling. Is it this one that is smelling? Smell. 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 Let's remove this one. are saying something. Cold extraction. It's hot one. We are eating it. With cold extraction, you can use another extract for it. Another liquid. You can use methanol. You can use ethanol. That's cold extraction. So you just need to do is to soak it in your methanol, maybe overnight or 2 days. Then you extract it. This one is hot extraction. Once it's very hot now, you see, just settle it down. Then we extract it. So you can use methanol, ethanol, or this process for it.
What we are considering is the effect of temperature on the properties of the material.
Is this extract?
So I think, should we be varying the temperature from
No. This one is just to extract the liquid. You don't need to vary the temperature at all from there. So just this when you want to calcinate. When you want to do calcination, that's when you can vary the temperature. Maybe after you have gotten your sample, if you want to vary the temperature, maybe you want to calcinate at 100, at 200, at 400, at 600. You want to look at the effect of that calcination on the material. So you can vary it 100, 200, 400, 600. So you go and characterize and see if that heating effect affect the material. So that is in that process. So I hope somebody is timing it. Yeah. Okay. It's a very simple thing. I think we are watching. Okay. So we have done it already, and the procedure step by step is with you. If you follow the procedure step by step, you don't have any issue. So we have done it. We have measured the liquid content, because it seems something is supposed to have higher speed than this, maybe because of the generator. So your meal, you measure it. This is maybe we have changed something there now. We change it to 200 mil instead of 100 mil because the speed was very low. So we change it to 200 mil to 10 gram. Okay, 200 mil to 10 gram of the something. So that's what we are stirring now. Okay, so 200 mil. So we are going to stir this and heat at the same time, to 45, Abi. 45 minutes. So after that, we'll bring it out. Once it's cooled down, then we extract it. We need the extracts for the sentences. Okay, that's the first procedure, and that's what we are going to do now. The second procedure is to prepare our ferrites. Once we get the ferrite ready, we can now prepare it one after the other with the surfactants. So we are doing this one now. This one is already made. This one is also already made. All we need to do is to dissolve it in 50 ml at lower temperature, because it's not readily dissolved in cold water. It has to be dissolved in warm water. So stir it, we dissolve it, then before we now use it. Okay? So that's what we are going to do. Next, once this one is done now, we'll prepare our zinc ferrites. Okay? Now, let's measure the something down, then we'll know what to do. Go to the procedure again. So we are using zinc ferrite preparation. 0.5 mole of zinc ferrite to 0.2 mole of what? Of iron nitrate in 50 ml of distilled water. Okay, 0.1, 0.2, right? 0.1, 0.2. So if we do this, good morning, Prof. Morning, sir. You're welcome, sir. So in each material you look at, they have molecular weights. If you check this thing, it has molecular weights. the molecular weights play a very key role there. So you don't just throw the molecular weight away. So if you look at each one of them, like this now, we have to improvise, change this. Okay, we're using sulfate, ferrous sulfate, and zinc sulfate. This one, ferrous sulfate, has molecular weight of 278.01. 278.01. We're going to use it to calculate the gram we are going to use. This one has a molecular weight of 287.54. So we're going to use it to calculate our gram. Very important. And yeah, you can write it. Mm. Yeah, we can use it for any of the application, but we are considering the dielectric properties of that material. We want to look at the dielectric properties. What are the dielectric properties? The electric conductivity, the resistivity, all those dielectric properties. Yes, it's the microstructural properties. We're going to look at it. What effect does each of them is playing on those properties? We're able to know whether they are increasing the property or they are reducing it. So we want to know. So you can as well use it for biomedical application. Okay, it's also good. You can as well use it for biomedical application. So we have the molecular weight of each one of them, as it has been written on the board. For ferrous sulfate is this, and for zinc sulfate is this. So we use this now to calculate the gram that we are going to dissolve in 50 ml. Okay? For each one of you, we are going to homogenize them in 50 ml of, give me that marker. Okay. So for each one of them, we have to get the mass, so we have the molarity multiplied by the molecular weight, then multiplied by the water content you are dissolving it, then divided by 1,000. So you have to do this calculation. You do this calculation, you get the quantity of gram that you want to dissolve. Okay? 50 ml. So if you're using 100 ml, so you put 100 here. If you're using 50 ml, you put 50 here. So we are using 50 ml, okay? And for zinc sulfate, we are using what? 0.1. Am I right? This one is 0.2. Is that correct? So if we are to calculate this one, so the mass will be equal to what? 0.1 multiplied by, what's the molecular weight? This one. So 28.287.54 multiplied by what? 50. Divided by what? 1,000. What is the answer? Sorry. So shift small. So what is the answer? Divide it. 0 point what? Try it. Divide it now. 1 point. So this one is what? 1.4 what? 4.3 what? 37. So they are approximately to 2 decimal places to be what? 4, right? In gram. So do the same thing to this one. If we put this one will be in this. For the ferrite, that will be 0.2, right? Multiplied by this one, 276.01. So what do you get for this one now? 2.76 gram. So we have this. See that the two contents we are going to dissolve in 50 ml. So I've converted it to what? To gram now. Okay? So that's the first procedure we are going to. So from there, no, I'm not cleaning it. Who is timing this one? Okay, good. So if we have like 2 heater now, we can just be performing it simultaneously. So why this? We are waiting for this one. Yes?
Acidic material or acidic reagent is involved. We need to take the pH.
Definitely. If you want to, you test pH. If you want to, it's very important. You'll be there with your pH meter, which you continue to take. If you want to wash, you wash until you have a neutral value. Like this one now, we are going to wash. In the process, if you are washing, we wash because we are going to precipitate it with sodium hydroxide. So sodium hydroxide will help us to precipitate the material. So we shall wash it away with distilled water and ethanol. Wash it away. Okay? Very important. You take the pH value of every one, stage by stage. You wash, you take the pH value of it. Very important. Okay, good. Yes, you can. You can. Yes, you are doing work. You are trying. We need people like you. How many minutes left? Yes, we are going to. How many minutes left for this one? It's up to 30. 15 minutes, okay. Okay. So this one now, we are going to measure that one. Sorry. No, let's leave it. We need so that this thing can be going on. So we'll take our measurement now for zinc ferrite, ferrous now. So we have 50 mil. Yeah, take. Wait. Oh, we'll use this one. Fresh distilled water there. It's all right. Yep. Okay. Give us 50 mil. 50 mil. Yeah, just continue. When you get there, you know. Reduce it. Put it there. 60. Just need 50 mil. Okay. So we have 50 mil. So what is that? Yeah, bring it. Cut small. Yeah. No. Courage. Yes, so that you will not be staining. If it's paper, you know, it can cause corrosion on the material. So you neutralize this one to 0. Yeah. So we'll measure our, for ferrous, we'll measure 2.76, right? 2.76. Zero, zero. So put 2.76. Two point 2.76, right? So 2.77. So we just transfer it to the liquid. This is our 50 ml. Okay. So don't use this one to measure the another one. Then if you are using it, it's better you have two of this. If you put this one now in this one to contaminate this one. So I think I have two. Let me check. Cover that one. Let's see how small. So we are measuring what in this one? Zinc sulfide. 1.44. So we measure 1.44 gram. Yes. 1.44? Yes. So put it in this one. Yes. So if you have another stirrer now, you should just be stirring this one. This one will be, yes, getting ready for this one. So once you have this procedure, I think you can, it's not late for you. All you need to do, go online, get current journals, look at what they are doing. It's the same procedure. You can replicate it. If you can replicate a particular journal, then you put your own constraints, then it becomes your own article. All you need to do is just to change parameters from what they are doing, change parameter, follow the procedure. Change the parameters, then you get something. Look at some of the medicinal vegetables in your localities that is very good. Like utaz is very good. It's very good. We use it. We eat it. You can also use it as a mix of like scent leaf, moringa. There are many of them. We've used guava leaf. Guava is also good. I've seen somebody use there's one water tamarind, something like that. There's one black pepper. One black pepper is also very good. These are things you can just check your environment. No, we have different vegetables in our environment. Look at the one that is very good in your locality that people don't eat often. The white people, they don't have it. Are you getting my point? It's not grown there. Utaz, I don't know if they are eating utaz, but we are eating it and it's very beneficial to us. So these are things that you can actually improvise. By the time you put your work in order and you compare it to what they have done, so this is good. You don't know how you came about the leaf. It's publishable. You publish your work, you go. So don't wait for anybody to come and push you here and there. It's research. So all you need to do, look at what is obtainable, compare your work with the current literature. Once you are in the same train with them, you are on the expressway, just fly. Okay? Check the SRD. If you are getting the same peak value with what somebody who use one chemical something is getting, you check your UV, you are getting good result under the same UV range. You check your FTIR, and you have your functional groups are very accurate. You check your SEM, you have very good morphology. Then try and apply it to anything you want to. That's solar cell. One of our researcher in our group use maize husk, this corn, the husk. That's what he used. And he published in a very good journal. And one of the things that even get him very good, he got a fellowship. A fellowship on Fuller Fellowship for using it. Yes, guava leaf. Acetone, yes, that's wet, yes. Extract it. Yes. Very good one. So it depends on you. Then we also use polymer. What we are using today is part of it. This one, this arginate, sodium arginate is a polymer, it's a biopolymer. Chitosan is also a biopolymer we're going to be using. We want to compare it. I just developed this research. I've not done it before. It's a new one. So we want to look at the effect of sodium arginate, chitosan, and green. Let's see which one is more effective. Is it the green or the chitosan or the sodium arginate on the properties of this compound? You can now draw your conclusion that, oh, this is better, or this one is better, or this one is better when you see your results. Okay? You draw your conclusion, you publish it. As simple as that. If you want to apply it to anything, you can apply it maybe on supercapacitor, solar, or medical aspect. You can apply it to any direction. So that's why I made it open. So once you get the result, if you characterize it and the result is very okay, then we look at in which area can we tailor it easily. Then we go ahead with it and do that. So I think this one should be done by now, have you? 6 minutes. Maybe we have to discard the 6 minutes. Then we can run. Okay, the root. That's serious. 6 minutes. Let's stop it. I think it has. Let it rest.
When he leaves, very, very good. That area. So look at that.
To allow this one to go, we don't need it for now. So let this one cool. So while we get this one ready for give me one spatula there. I'm supposed to have magnetic something. Let's see that. No, I want to remove. I want to use this one. So it's stir faster. Give me one beaker, small beaker. Let's wash it. Wash it there. Wash it first there. Morning, sir. You're welcome, sir.
Come when the soup is ready, it's ready.
Put it in this one. Courage. These small beakers, just rinse them. We are going to use to extract this one. Rinse all of them. Sir? No problem. You want to give me money? The way you are opening your purse. I hope I will get all this picture. Oh, that's good. Get up to 4. Remove that one. Put it in the other. Put it in the, yeah. No, we are using filter paper. Bring that net first. Take a, rinse it so that we first of all use it to. Forget that cloth. We'll just use this one. So we are going to separate it. So that's the next step.
Let me. Boy, you look so. You are not in the code.
Give me this. Give me the
go.
spatula. Spatula there. That's spatula.
Yeah, you left me. No problem.
No, he's just resting.
So you have to you separate the content. So you separate it. Use this. You're supposed to use another sieve. Yeah, this one again. But I don't know. I left that in. So we now use filter paper last to separate it. Let it rest a while. Is it? Touch it, let's. What is it? Don't touch. Still hot. It's still hot. Yes, still good. Huh? No, I want it to go down completely before we put this one. Yes. So I want it to go down completely. We can cut exactly. Put. Yeah, use that one. So we're going to filter this one further. Filter it from, this is the first stage of filtration. We have about 3 stages of filtration. We use this net, we use dark cloths, we have yes. Then lastly we use filter paper. So to do the filtration, then after filter paper it will be very clean. That's when we can now use it. So in 3 stages involved. So from there, it will be ready for use. If you are not using it immediately, it's better you prepare it daily if you want to use. Otherwise, they can easily attract it to become contaminated. So unless you have free refrigerator in your lab, so just keep it in a bottle, keep it in your refrigerator, at very low temperature, so that if you want to be using it subsequently, you can be using it. Otherwise, if you just keep it anywhere, you can't use it again. You have to prepare another one. But if you have a refrigerator, you can keep it in your at a very low temperature. So whenever you want to use it, you bring it out and keep it in the refrigerator. Okay? If you prepare it in large quantity and you want to use it for maybe more experiments, so put it in a bottle, keep it in your refrigerator after extraction. So it will be very good. Otherwise, you have to repeat it.
Can you leave it for as long as 1 week?
Yes, once it's in a very cool environment. Let the temperature be very, very good environment. Put it especially in the refrigerator. So let it be there. It will still be good for use. So you want to leave it outside? 11. Where? No, where? Which part of the north? Castina now. Like Fontoa. Fontoa. Zaria. Up to 11. Wow. That's good. It's very cool though. Last time I experienced that code was in Pakistan. You'll be in your room like this, you'll be shaking, your heart will be shaking. Then you have to, if I want to sleep, I wear clothes, and I put on pullover, not this ordinary pullover, the thick one, I'll put on pullover. So always with your sauce. Always with your sauce, you put on your pullover. You now use this thick bed sheet to cover yourself. Yet I will still on my heater. I will still plug my heater 24 hours. Heater is working. No, that place is highly. There was a time, sir, many people died as a result of the cold in Pakistan. A lot of them died. Too much cold. Too much. No. The weather is favorable. And when it is their winter, the temperature can be as 50. Very hot. They can record 60. You can't go out on a sunny day like this. Your head will be burning you. To be very extremely hot. Extremely hot. But we are lucky in Nigeria. I'm telling you. Do we have it? Do we have? Okay, with that, yeah, this one is okay. You have another one? Check if you have another one.
Hmm? This second is
Okay, this one will be better. Give me that water. That small water. Baker, that's water. Just need 50 ml. Just can get 50 ml.
Okay, still this needs 50
You need 50 ml.
We're able to get up to.
We are still going to see it again. But we should be able to get to that.
Put him in the middle. Okay. Go to the other side. Sir, can we help you? Do we have anything to do?
You can go ahead. Everything there is doable.
You. Let me do as if I'm trying to put this. Let's go.
Any picture you snap, you must copy me.
It's okay.
He's trying.
I don't want to expose you to air. Or let me just do like this, as if I want to pour the sample. Can we go on?
Yes.
Okay, the tag. Sorry, the tag. It's important. Thank you very much. Thank you, sir.
You're welcome.
First one I snapped is my phone. It's okay.
Okay, good.
I think it's
It's still hot.
still coming up. Going down.
Want to filter it? So use your filter paper. So you use filter paper. That's the last stage of filtration of the extract. To make it give me the foil. Just cover this one. Don't worry yourself. It's okay. It has gone down now. Done. So you have to filter this. You have to do it gently. You observe it. So this is the final stage. Supposed to have second stage. We have a filtering cloth. Supposed to use it after this one. We use that one before this one. I left it at home or in the lab. So let's just go ahead with this. So if we filter it, whatever we get now, we can use it. So you continue to repeat it. Once it stops, once the holes are blocked, you repeat it. You put another one. Continue to filter it until you have enough solvent that you can use. Yeah. So this one is ready for use. It's not hot again. So we can put this one where we start. How many hours is this one? How many? Shock. The combination now. 1 hour. I mean, for 1 hour. Yes. At room temperature. Okay? 1 hour. So that's what. So time it now. Time it. Okay. So we are going to stir this one for 1 hour. Yeah, the mixture of the two compounds. That's the precursors. Yes. So that's what we miss here. To be stirred for 1 hour.
What is the volume of the distilled water used?
Huh, you are not following us. Yeah. 15 mil. That's what we use. That's what we use to calculate. Abi? 15 mil. So from the calculation we know.
The 50 mils was for the surfactant.
No.
Not the surfactant.
Yeah, we use 15 mil for the two, the combination. We are still going to use it for the surfactants. So to dissolve the surfactant, the chitosan and the arginate.
Yes.
When we want to dissolve it, we still use 15 mil.
Okay.
That one's separate.
Okay.
So this one now is to prepare the precursors together.
That also means that we can prepare only for zinc ferrite.
Yeah, that's what we are doing now.
That one is mixed.
That's zinc ferrite.
No, he is talking about the filter one now.
No. He's talking about zinc ferrite.
Yes.
This is zinc ferrite.
What about the filter one now?
This one is the extract. This is the oxymum gratissimum. That's what we are doing here. Because it's a long process, I wanted us to do it first so that, because this one will take time. That was why I said let's do it first so that while we are waiting for it, we'll be doing another process. This one will be just be getting ready for us to use.
Sorry, sir. I still have questions.
Go ahead.
Now, we did a decantation process
Yes.
to get the extract.
Yes.
Isn't it? Now, the extract, later on, you see diluted. Is it with the zinc ferrite or with what? Or normally distilled water for this filtration process?
For this one,
Yes.
we have the
The result of the decantation we put there.
yes.
So now, what is the fluid you use in diluting the decanted
Distilled water.
distilled water?
Distilled water. We use distilled water. We measured how many gram? 200 mil of water. Then how many gram of the oxymum? No. 10. 10 gram in 200 mil. That's what. Yeah, that's what. It was 100 before. When I discovered that this the generator cannot carry to make it 200 so that it can. Yeah, it depends on you.
Just do manipulation.
So we use 200, which is still okay. Some people even use 1,000 for 1,000 mil for 10 gram, so that you can easily get the extract out. If it's too thick, you will find it difficult. So 200 mil is okay for 10 gram. Some people use 500 mil. 500, 10 gram. Yes, which we can easily dissolve it, can easily get your extract out. So if you want to use a cold method, use methanol or use ethanol. Cold method, just soak it either overnight or 2 days. It will soak very well, then decant it as well. You get that's cold method. So this is the zinc nitrate here. This zinc ferrite is a combination of two compounds. So zinc sulfate and iron sulfates. You get it now? So zinc sulfate, and this is what we have calculated here. The sulfate, ferrous, and what? The zinc. So we've calculated it. We are using double up because normally we're supposed to, this one time you are calculating from literature, the iron value is to be more than the other value. We use 0.1 for this, we use 0.2 for this. So iron value is to be more. From literature, what I have seen so far, so this one is to be more, higher than this, almost ratio 1 to 2 always. 1 to 2, 1 to 2. The ferrous will be ratio 2, the other one will be ratio 1. We use 0.1, we use 0.2. So after calculation, we have this. So this is what we dissolve in 50 ml, right? So that's what we dissolve in 15 minutes. So we are going to stir it for 1 hour at room temperature. So while we are rounding off, we'll precipitate it with sodium hydroxide. Sodium hydroxide will help us to precipitate it. So after the precipitation, we wash it. We wash it so that the dissolved sodium hydroxide will be washed away. Okay? Then we can now heat. Once we heat it, we're now beginning to add this our surfactant to the solution. Okay? It's going to be one after the other. Are you getting it now? So which means you are going to have how many samples? How many samples are we going to have? No? No? How many samples? It will be how many samples are we going to have in all? So you dissolve it now. It's 3 now. Yes. Yes. 3. 1 for this, 1 for this, and 1 for this. So you can make it 4. We are going to make it 4. Do you know the reason we are going to make it 4? To have a standard. One we can use as a reference point. So that one is without this, without this, without this, so that you can compare your results. So the one without anything, that's the reference sample. So that will be reference sample. So when we added chitosan, by the time you characterize, you'll now be able to compare this one without anything to the one with the surfactant. So is there any variation? Do you observe any variation? Are you getting it now? So that's the 4th sample. Okay? So. Well, it's very important. Apart from that, you're working in the, if it's in our lab now, you may not be the only one working in the lab. So if I'm working with this, somebody is working with titanium dioxide there, another person is working with another poisonous something there. There's no way some particle will enter your own. So when you characterize your sample, you discover that from your EDS, you'll be seeing all manner of elements that you didn't synthesize. Then begin to wonder, what is titanium doing in my sample? So, and if you send such article out, the reviewer will question you. They said, you dissolve zinc and ferrous. Where did you get this titanium? They'll question you, and they will ask you to go back to the lab and repeat the experiment. So you can imagine what. So it's better you take your precaution from the beginning. Take your precaution so that when your result comes out, you know that it's going to be what? A pure compound you deposited. Okay? So that's why it is necessary you take your precautions very well from the beginning to the end to avoid unnecessary impurities to enter into your sample.
Because in reporting the methodology, this has to come in.
Yeah, everything has to come in. Everything here enters your method of step by step. You must tell them, why did you take this step? Why did you take this step? You must tell them. Stage 1, if you check what I gave you, I said step 1, step 2, step 3. You follow it step by step. If you are reporting, if you are doing your PhD, you must report step by step. Stage 1, this is what we did. These are the precautions. Stage 2, this is what we did. These are the precautions. Stage 3. Anybody want to know, want to carry them along, and people want an experiment that is repeatable, so that if they just go to your thesis anywhere, they just pick it. Somebody want to replicate what you have done. So if you don't give them step-by-step procedure, they can't replicate it. So it will be a big challenge. So give them the procedure, which I have done. Follow the procedure one after the other. Then you get the output of the results. So, yes. Yes. Yeah, you observe it. Good. I was saying it the other time. I know many people don't pay attention to it. Good. Thank you for the observation. When I prepare, I use nitrate. Yes. Now we are using sulfate. Yes. So I couldn't lay my hands on the nitrate when I was coming. So the combination I could have was sulfate. So, but they are still in order. It has zinc nitrate, zinc sulfate, zinc acetate, zinc, which other one there? There are about 4. So you can use any one of them. But I want uniformity. That was why I was looking for iron nitrate. I couldn't get iron nitrate. I have zinc sulfate. So now, okay, since I have the combination of this one, so let me use this one. So it's still the same thing. So instead of nitrate, we use sulfate. Okay? Thank you. So we are in order. So you can see the procedure. It can take you like, for you to produce this now, maybe 1 week if you are consistent and if you know what you are doing in the lab. And as I've said it yesterday, the design of the experiment is very important. And once you have the design, just write it out step by step. You can just follow your step. If I finish this one, what should I do next? You go to the next one. What should I do next? You go to the next one. It will simplify your work, and it will be less stress for you. Otherwise, you just be thinking, what should I do next? And once you make a mistake, oh, you go and discard it and start all over again, which is more stressful. You can imagine if I've done such an error before, I have to discard it, start all over again. You can imagine this one now, we have to steer it for almost 1 hour. And at the end of 1 hour, you discover that, oh, that was an error. What will you do? You can't continue like that. You discard it, start all over again. So, precaution is very important. Write out your procedure. Be specific with the procedure so that, like my own, if I show you my book, okay, let me show you so that you know what I'm doing. I have a book where I used to write everything I'm doing. So this is my book. This book, I don't joke with it because all my experiments. It's when I travel for postdoc, I've been using this book. So stage by stage, everything I want to do, I write it down. All my experiments are there. I will just every calculation that I want to do. Now look at this one now. This is a complete experiment. I wrote the topic. Once I get the topic, I'll write the topic. I write the method. I write all the material I want to use. I'll write them out. So preparation of this. I wrote the preparation down, step by step, step 1, step 2, step 3, down, 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 down. Down, 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 all to the point when I will calcinate. I will now even reach to the point of characterization. I'll write it down. See, down, 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 down. So, it's another experiment. Down, 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 step by step. It's another one. Hold this one now. Majority of them have been published, step by step. So write it down. So don't just joke with, don't discard it, don't joke with, don't just write it somewhere you can easily throw it away because you may still need the procedure for another experiment. So document your work very well. I've been using this now since 2019. 2019, it has been like that. I don't joke with it. Anywhere I'm going, I go with it. Because I may need other things that will guide me. So I've just quickly make reference to this book. So all the experiments that I've done and I'm still doing is there. So see, one after the other, each experiment, I have a template for them, even to the point of characterization. I have a template. So that another thing, you have to be very careful. If you don't label your sample very well, once you miss it, you have to start all over because you cannot differentiate this one from this one. Whether this one is one coated with chitosan or this one was coated with arginine, you don't know. Then you're beginning to think, oh, how do I know with the one coated with? It will be a big problem. So you have to be very, very careful. You label your sample from the beginning till the end. Until you send it out for characterization, you must label it. And use the same code from beginning to the end. If you are using A for 1, that's what you will use until you characterize it. So you don't change it so that it will not mix up. If you are using A for this, or A1 for this, A2 for this, A3 for this, till you characterize it. You're using A1, A2, A3, A4. So when you want to characterize, you now characterize. Then after characterization, that's when you are free. Then you know that you didn't mix it up. Then, that's all. So when you are now analyzing your samples or your results, you still make reference to that code. Because that code will also guide you in analyzing your what? Your sample. You know that, okay, when you are discussing, you know that this is sample A. What is the content of sample A? You discuss it based on the content. Then we compare the discussion of sample A. You compare with what? Sample B. You compare with sample C. So that comparison is very, very important in your discussion. That comparison, very, very important. What do you observe in sample A? What do you observe in sample B? What do you observe in sample C? Because if you don't discuss your work very well, your reviewer will say, no, you didn't discuss your results very well. You must discuss it very well, that this is what I observe in sample B, the morphology, whether it's rod-like or whatever like. In sample B, it's like this compared to sample A. In sample C, it's like this compared to sample A and B. In sample D, it's like this compared. So you have to, one after the other, discuss them in each characterization. Then you go to another one. Then you now conclude. Then you, at the same time, you now compare your results to the current literature. That my results is similar to what so obtained in year 2022. Using similar thing on this. So you can be able to compare your work with one or two what references. Okay? Each discussion, compare it with one or two what references. Then you are secured. Otherwise, if you don't compare, the reviewer will send it back to you. He said, are you the only one doing this thing? Somebody must have done similar work. Why didn't you compare your work with what that person has done? So you compare it. Okay, that's the essence of literature review. If you have done your literature review thoroughly before you get a topic, you don't have problem. So from your literature review, you can lay hands on one or two people who has done similar work. Then you reference them in your discussion. Okay, very important. So these are procedures that we need to observe. Very, very important. Okay, off that, you can remove it from the code, or yes, remove that one. So while we are waiting for this, I think we can be doing another thing. So how far have we gone with our review? How far have we gone with our review? So that we'll be doing another thing while we are waiting for the next stage. So let's continue our work. Yes, that's the yes, we'll change it time to time. Once they are not dropping, we'll change it. That's what we'll be doing. We'll continue changing it until so in your group, how far have you gone? Have you distributed the subtopic?
So
This, our work must be completed before we leave this place. We have to complete it before we leave this place. It's a must. So, at least on Saturday we are not coming here. Saturday, Sunday we are not coming here. So everything must be. Today is Wednesday. Everybody should know what he or she will be writing on today, so that tomorrow overnight, Friday, Saturday, Sunday, you are not going anywhere. Is anybody traveling here? Yes. Shama, are you traveling? No. I'm traveling. That weekend, at least you should use Saturday and Sunday to do the major work. So tomorrow's night, this night, so each group now, the subtopic now should be distributed today before we leave here. So distribute your subtopic to individual. So by now, be searching for articles on how to discuss your work. And as you are doing it, get information back to your coordinator so that you can track you, that you'll be on course. Okay? And as I've said, don't do copy and paste. If we subjected it to plagiarism and your section is highly plagiarized, you will start all over again. We'll make reference to your section because we are going to do section by section. If your section is highly plagiarized, you will start all over again. And we must complete it before we leave here. So please distribute your topic now so that everybody will be looking at one thing or the other, be thinking of what to do. Okay? While this one is going on, we must engage ourselves in other thing. So what you need to do, once they stop like this, just repeat it, you continue. So all we need to do, you burn more of your filter paper. So you remove it, yes. You remove it, you turn it to another one, okay? So the particle, you continue again. So that's what we'll repeat. Exactly. If we use that one, it will reduce it. All those blocking particles will be out of it. Corey, where did you keep that nylon? That okay, I've seen it. Thank you. Sir. Okay. Okay.
And it is not really in line with what
we are doing. Okay.
we have to abandon them and then go straight to what. For example, a group will be giving something on this, a review on a topic like this.
on this one.
So this is the way we do it. And it's just like you're doing a PhD. And then the topic you have, you try to do some literature review on it. So we are going to do a literature review on this. We can reframe the topic, and then it becomes a review for a group. Maybe we'll look at another topic we are going to do, and do it as a review to that group. So because I saw where a group is talking about nanoparticle coating, something like that. That's correct? Yes.
Group 2, Abi? Or the group?
So if we finish the review and probably publish it, it ends there. And it doesn't give us a continuation of
To this one.
this work we are doing here. So once something on what we are doing here that will enable us to continue even when we get to our stations. I hope you understand what I'm saying. So group 3 is doing something on simulation. That is good. So they are trying to simulate a material that can be used for solar cell. If you have interest in that also, because each group will also make a presentation. We'll now look at the interest and where people are driving at. While we wait, if you have a question on what this thing that is saying, then you can ask your questions.
Some perovskites. It's wide, have you? General nanotechnology.
And I saw the article that was sent by Lewis that somebody commented already on that. But we want to tailor this thing to a particular issue so that once we pilot that, we are sure what application can this be used for. And then what material are we looking at under that review? So that we don't have a broad issue.
Okay, what I will do, let me just search out 1 or 2 review on this, maybe relating to either supercapacitor or battery or something like this, or an energy. Let me search. Then if I can get anyone, I will just share with us.
I think there is a review on lithium-ion battery that might.
Okay, Mike. Okay.
So maybe we can get that one. There is another review published in the Journal of Energy Storage where we talk about racing cases. There is one also in the Journal of what is this? So if we can get that, it will help
Okay.
those who are working about it.
Do you have, Prof, that mic sound, do you have it?
It's open access.
Okay, well, it's attached to your research gate. Okay. I think we can track it. Maybe you didn't set it. There's a place they set it for to start with. Yeah, it's newest. It's in newest stage. It's newest. I think that is the newest one. Kelechi Koala. The one might just publish. Which month? Currently, this November. Maybe they've not attached it. I don't know. Is this girl now? Biannual African Nano Conference Workshop on Application. I don't know where she published it from. Poster. Where did she publish it? I just attach it. Google, you can easily track it in Google. Let me check. Perhaps it's not yet attached. Is this one?
Okay, this is a big chapter.
Okay.
I'll put mic. Let's see whether
Let me check mic.
right. Okay. Watch it.
Okay.
Watch it. I watch it. That's really.
Him.
What is this? Look at it now.
This one. Okay. This one.
Yes.
Research progress in solid state synthesized lithium, manganese, phosphorus, cathode model for lithium battery.
So battery application. So maybe we can, instead of this,
Lithium, manganese.
yeah, we can use ferrite
Okay.
for battery.
Let me search generally for battery on.
No, you have to be very specific, otherwise it will be.
Yes, I want to search zinc ferrite. Zinc ferrite. Nanoparticles for battery. It's such. This network.
I think this would be a very good topic for review. If it has not been done.
Okay, fair non-requesting composition.
For what?
Carbon dioxide decomposition. Or let me just, we can go to, let me just use, let's use only ferrite. Let's see.
Two results from that.
Yeah, 2020. Let me check.
Put S on that ferrous. Everything looks like
I don't want to use, so let's use
write it in this
only ferrite.
chemical formula.
Okay.
Capital Z and small n. Yep. Is it two?
Or 3.
Yes,
Fe2, yeah.
Come with two results.
Measurement produced by chemical spec analysis. 1000.
So how long have we been this thing?
Was one. One.
1 hour. Instead of staying on this thing, why don't you go to Google?
You should use Google Direct.
Google Drive. Because Google can bring from other publishing houses. My battery is dead completely.
For
Which one is
10. Yeah, that one. Like this one. For nanoparticles, sentences, characterization, and application in electronic device.
Yeah. This could be very close one. We can. Is this a review now?
It's a review. It's a review work.
So,
Material science and engineering.
so we can modify it for.
And they use ferrites for electronic device. Nanoparticles.
He said electronic device, we can tailor it to, but it means there's no much work done to tailor it to energy application.
Energy storage device. This one for energy storage application.
Yeah, for energy storage applications. This one is a book.
Okay, it should be a book.
I think so.
Yeah, it's a book. It's a book chapter.
So one can decide to tailor it to zinc. You see there are publications, zinc ferrite.
They have more of biomedical application than energy. Yeah, it's more useful in biomedical.
And there is something.
Okay.
linking abundant resources and low-cost process for sustainable energy storage.
This one is also good. Yeah, this one.
Is
Nickel zinc ferrite. Yes, you can also work on it.
okay.
Soldier wrote an application in high temperature superconducting magnetic energy storage for voltage. Yeah,
So we can
it's not necessarily zinc ferrite. You can pick other ferrite.
the use of specific properties of zinc ferrite, innovative technologies.
Yes. Ferrite for energy storage application. Like that one now is also good. That one, this last one. You use the selected 3, 1, 2, 3, nickel, cobalt, and copper. That one is, it has PDF now. Can you get that PDF? That one has PDF. Dielectric energy storage, density storage, electrospon, fiber, metal. Let's get that one. If you can get 3 of them, you can follow it. Is it one a review? Is it a published work? It's not a review. Yeah, it's not a review. It's a published work. Let's see that application. Okay, they use it for dielectric.
No, my thinking is we get this one that was synthesizing. Synthesis of structure, characterizations, and then application, energy storage. One can put up so many things and then
Okay, sentences.
just like zinc ferrite synthesis,
Characterization.
characterizations, and application of zinc ferrites in energy storage device.
So for the 3 of them, for the 3 group,
No, only one group should handle that.
let me check something like that. I hope we are timing that thing. Oh, that's good. So if you get anything, just let us know. Synthesis, characterization, and application of ferrite materials. Let's look at diverse application of it, and let's see anyone we can tailor our review to. Just look at the diverse application of it. You can easily look at which one can we work with. Hello, sir. Hello, Ekusha. Hello? Hello, sir. Yeah, Ekusha. Fine, sir. Ekwale, sir. Fine, fine. Okay. Okay. Only the frame, be filled in frame, eh? Okay. Okay. Awesome. Awesome. It's all right. No. Yeah, it's true. It's all right. It's all right. Awesome. It's okay. It's okay. So what do we come out with? Did we get anything? Okay. Book shot where's the heading? Okay. Preparation, characterization, property application of nano zinc ferrite. Well, that's good. What are the applications? Let's check all those possible applications. Okay. Okay. This one, zinc ferrite over the past. They use it for solar energy, have you? Okay, we use water splinting. Water splinting. Okay, that's what you use it for. It's for water splinting. But it's just one of the applications. So if you can search for more, save this one. Oh. Can you download this one? Yes, save it if you can. I'm coming here. Ferrite nanoparticle systems and character application. Yeah, it's an electronic device. Yes, it's another one. Can you download this one?
Yes.
Yeah, download it and save it. Search for more. Search for another one. Review on recent advances of zinc substituted cobalt, ferrite nanoparticle system characterization, and diverse application. Wow, this is also wonderful. It's also very good. Can you download this one? Okay, it's not downloadable. Copy the DOI, send it to Prof. Maybe Prof can download it. It's also very good. It's also very good. Yeah, which year is that one? Show it to Prof. Show the title. Students and characterization of ferric vanadate nanorod. Efficient electrochemical detection and ascorbic acid. It's also very good though for electrochemical detection. Can you okay, it's PDF of it. Download it, let's see. Let's read through it. So we can see the subtopic under it. Okay, you should get another one. Okay. So this is a book chapter. Synthesis method and application of ferrite. Yeah. It will be useful anyway. Spinel, ferrite, and structure for energy storage. Yes. Download this one. It's a book chapter. Download it if you can download it.
So I think what we just do is get a collection. This one is
Manganese. Okay.
So if we can get this, we only replace manganese with zinc.
Okay.
And there are
From synthesis to application. Good.
So this one they use for diverse applications.
Okay.
But we also have some application in energy.
Okay.
So if one is working on that, you just get to this, remove the energy part of it, take it, and then forget about it. That one, look for another.
Or alternatively, maybe for each, because they use for supercapacitor there.
This is anode material.
So sorry, let me see that table. Structural systems. Okay, electrochemical properties.
It's still electrochemical performance.
Okay.
So here they started talking about
This water splinting.
the water splitting. Yes. But in all, we can also do for various applications.
Yes, we can use. We may not limit it to energy storage. You can just touch various application of it for drug. They also mention drug, energy storage. They conclude, which is publishable. So we can select for maybe each group should have some group can have zinc, some can have manganese, ferrite, another one can have like cobalt or other ferrite. So they should just pick different ferrite.
So, but it doesn't prevent like the person that's already working on
that simulation. And that one is a different thing. He said he can do it because the way I'm looking at that one is only one that can do it. So it's going to be a single man work because others don't know that simulation. He can do it, which we can publish. We can publish while the entire group work on the review. Let him work on that simulation. Then later he will teach us through his presentation, which if everything all things being equal, everybody can, if it's publishable, look at it, we publish it, that one separate. So while others can contribute easily on the review. That's the way I'm looking at it. So we will not stop that. So far he said he can generate it within 2 weeks. So Why?
He has said he's going to publish it in our journal. So
Okay. So let him go ahead with that one. So this one is this one downloadable?
you already downloaded.
Okay, download it. You can maybe forward it to that to each group.
I don't have.
Forward it to me. Forward it to my mail. Forward it to my mail. So that you can share that one. I think it's very good. Yeah. Sent it to my mail. Okay. Is in the experiment. We want to add the surfactants now. Add the surfactants. Sir?
I'm sending you one that.
Okay. Do you have another one? Preparation techniques for zinc ferration. Wow, this is so good. Optical, electric, and magnetic dielectric property of zinc. Wow, this is very good. Let's see if you can get it. I want to check on this one too. There are nano sheet to combat food. To be some prof download this one. This one. Relevant techniques for zinc ferrite and the applications. I think similar to that one.
When is it published?
Material today. Is a proceeding.
When?
Today proceeding. 2022.
2022.
Mm.
Okay, let me try whether it can appear on my.
Just save the copy this one, this link here. Copy it and forward it to
Send it on my.
forward it to prof. Just copy that link. Okay, we downloaded. Someone sent to me, then I'll forward it to them. So check your group something. I forwarded an article to you now. Check your group. All the groups. Is it? Are you the one that sent this one? It's not you. Let me check. To Prof. Okay. Don't worry. Prof already downloaded it. It's already downloaded. Let me check this one. I don't know who sent this one. Let me check this one. So check. Check. Have you checked your group? Hello, sir. Okay. Nǹkan tó sọ̀rọ̀ sí mi náà ni mo comment lé.
Nǹkan ní 9,000 skeleton ní 9,000 for me to finish nìyẹn. Yeah, let's see David stage yẹn for now.
Imagine.
Mo ní kó correct yín náà láì padà sọ̀ láì lẹ́yìn ó ti correct yín dáadáa.
Ọ̀yẹ́ kó correct ẹ̀ dáadáa.
Wọ́n ti correct yín, wọ́n ti pa wọ́n bá yín sọ̀ láì padà lọ́wọ́ láì padà.
It's all right. So in your group now, have you seen that one? So that one is on manganese, sorry. So each group can actually pick different ferrites. We have manganese ferrite, we have zinc ferrite, we have cobalt ferrite, magnesium ferrite, so which we can actually work on. So if you look at that one, it's highly explained, down. They use it for diverse application. So if we want to work on that, so any one you pick in your group, if you are picking zinc ferrite, then you now look at different application, we can tailor it to us. Maybe group 1 can pick, this one is already on manganese. So maybe you can pick maybe cobalt ferrite, or the next one is on, let me check. Okay, maybe the group should take this one. Second group should take the second one. Second one is on Are you in the experiment? Let me open the experiment. Yeah, first group now should work on zinc ferrite. Yeah, following that article. Yes. Okay, the second experiment will be on green synthesis of zinc, copper, and nickel oxide now. But this one is for biomedical. You can tailor it towards another application. We can have zinc, copper, and nickel oxide. Group 2. So search something on that, group 2. Search something on zinc, copper, and nickel oxide. You can combine the 3. Then group 3 should be on group 3, that will be cobalt substituted zinc ferrite now. Cobalt substituted zinc ferrite nanocomposite. This is a composite. That group 3 is a composite. A composite of it. Cobalt substituted zinc ferrite nanocomposites. Let's check diverse application, maybe used for supercapacitor or battery or energy storage. Check that one. Group 3 should check that one. Group 2, check copper, zinc, and nickel oxide. Check the applications for, you can check for supercapacitor, check for application, just check applications. Zinc oxide, copper oxide, and nickel oxide. And they make we are performing practical. That one now they can select either one of them if the application is wide. Okay. Ferrite. Okay, let's just use substitution. Group 2, right? No, group 3 is cobalt substituted zinc ferrite. That's group 3. Cobalt substituted. Cobalt substituted zinc ferrites. Nanocomposites. So group 2 can they work on the oxide, or they should work on another composite of it? Okay. It's group 2. Green sentences and diverse application. Okay. Zinc, copper, and nickel. Zinc, copper, and nickel oxide. Now, Prof, want to check something so that you will know if you can get. You mean? Yes, it will be good. Yeah, so that it will not be too diversified. It's already 30 minutes, right? I think it should be by now. Two minutes more. Okay. So we can now put on the temperature. So group 3, check that one. Cobalt substituted. Let's see if you can get anything on that. Cobalt substituted zinc ferrite. Cobalt substituted zinc ferrite. Check. Okay. Yes, cobalt. This one is what? So advanced zinc substituted cobalt. It's also good, but yeah, this is zinc substituted now. Yes, it's similar. So you can actually zinc substituted cobalt ferrite nanoparticles, sentences, characterization, and diverse application, which is very good. So save this one. But we are substituting cobalt on zinc ferrite. Yes. If you can download this one, download it. I think it's 30 minutes already. Abi? It's 30 minutes. So we can now subject it to lead to it. on temperature. So if you set the temperature to like 30 degree, so you can see that it has precipitated somehow. So we eat it for a while, then we now wash. Yeah, we'll continue to stir it. Yeah, while eating. Yes, see it now. So by the time it settles down, now you will see it now. Can you see the separation now? So it's already separating. So when we wash it now, you will see it very better. So let's eat it while stirring small. Did we time it there? I think, did we time it? Check that place. They will just check. We didn't, like the 15 minutes or thereabout. 30 minutes there. I think 30 minutes is there. So that's. So group 1, I think you can work with that one. That manganese. So what we need to do is to, instead of manganese, put what? Yeah, zinc ferrite. So let's start on that one. So all you need to do, get more articles, more related articles in that one. So we can get more related articles. Then let's see how we can divide it into subtopics. So we can actually work on different applications. We can even combine it with drug, battery, supercapacitor. That one, if you check that one, they use it for supercapacitor, they use for battery, they use for drug. So it's a review. It has to be wide. When you are discussing any topic as a review, you have to touch every aspect of it, all the area they apply it to. For good journal, if you want to publish it in good journal, you have to touch all the areas where that work is being applied. I think it's better that way. If we have 5 in the group. If each person can pick one application, that's for supercapacitor, for battery, you are going to check for drug delivery, for maybe dielectric application. So just look for anything on dielectric, anything on supercapacitor relating to that. Just write something on it, make your good references, and you'll be okay. And I believe one thing, for another thing that's very important, so that it will not give us problem when we want to be formatting it in terms of publication. I hope you can reference very well. What format do we use for referencing? APA. Everybody can use it. Is that they are using APA? For publishing, yes. Mendeleev, how many of us can use it? For publication, it's not the same thing the way you write your thesis. So there's a place we can even use your system. You can easily use. I want us to use the same format, so that when we want to format it, it will be easier for us. Because this is a review, we have many references, so it will be difficult for either the coordinator or the person that want to format it to suit the journal's something. At times you have to format it to that particular journal, so that it will be very easy. You can easily switch from APA to III or whatever. So let's use the same format. We can easily switch it without start repeating it one by one. Okay? Yes, that's what I want to do, Seth. That That one in our system, I think that one is very simple. There's a reference style in our system. That from the reference something is very simple, which we can easily touch. I don't know if these people they can connect directly to my system. We can just easily use that one. That one is simple. Open your system. It's there now. The one, you know that one. That reference. We can switch from APA to IIE, easily. Just click it. It will just everything we are align for you. If you know that one, so that one will be easier for us to use. So that because referencing for you to format it can take you a very long time. Yes, to format it very difficult. Emily, this one you can use this one. Sorry.
Percentage when the viewers try to look at it. So it's not all copying from people's work, but you also have to have a mental picture of their own, which will introduce and will keep
Your contribution.
draw it yourself, make it very nice. Painting, transfer ideas.
So, Prof, what are you saying, sir? We didn't get it.
If you are writing a review, you need to have a pictorial view of your own,
Okay.
of what you want to introduce into the review. For example, all these pages that he has here on the board, it's not a must to copy the page that somebody has already put down there.
Exactly.
You have to put your own
You can design your own sketch. So that you won't reference it. If it's your own, there's no need of referencing it. But if it's not your own, you have to reference it. But if you just look at this one now, so let me redesign it in a way that it will still carry the same message, but your own sketch. So you don't need to reference that one. So that's
And is there, I know there are softwares for doing this thing, this kind of thing.
okay. Do you have it?
I don't, there was one somebody introduced to me.
What is the name?
I have to check.
Check. I need that software. I've been looking for it.
There are softwares.
Check. If you can get it, I'll be happy. Just check.
So I want us to find out.
Yes, please check. If we can get that one, we can also introduce it. You send it to my mail. For the green sentences, right?
different method,
Okay. Green approach.
yes. So they can also translate to either zinc or cobalt
Okay.
what they want to discuss. So nobody's using Zotero.
They are not covers, and not everybody. I have not used it before, self. It's a software now, like Mendeley.
That's the first thing I introduced sometime.
Yeah. I've not used Zotero before. But I used to use this word reference. I'm used to that one. Because that one can really save for me. So if I want to write another article, I'll just go there. I don't need to even call it. It will just save for me automatically. Reveal on recent advances of zinc substituted cobalt fluoride and the percent. It is the one for group zinc substituted cobalt ferrite for group 3 now.
Yes. That's one for group 2.
Okay, let me download this one. I can see it. Okay. Facile green substances of cobalt, vanadium, nanoparticle electrode for high energy lithium battery. Okay. Cobalt, this they can put another thing, right?
So what we can do is we have cobalt is in that one.
Yeah.
So what is the other one again? Cobalt, what?
Copper, zinc.
Maybe cobalt, copper
Okay.
for various applications.
Okay.
Who was the person that came in this deputy director?
Yeah, the deputy director. Okay, it's Professor Oyelani. I've heard the name before. Oyelani. I think I've heard that name before. Yeah. No, sir. No, sir. It's just the filtering process, which we have started. We all know that, right? So, just added the remaining one, so that we can filter it. So, I hope we time this one. What's the time now? We have introduced it. We have introduced it to it. So, what is the time remaining?
Remain about 17 minutes.
Okay. Yes. Let me forward group 3. Let me forward this one to you. Okay. Did I forward one to you the other time? Did I forward one article to you? Okay, let me forward this one to you. Group 3. Group 2, they are the one working on green substances. They work on cobalt substituted group 3. It's still there. I went there twice. You know, that period was convocation periods. No time. In fact, as at on Friday, I was there. The secretary nowhere to be found because they didn't return it back to other offices. They said for visit to sign, it has to be with the secretary. I went there. Even the woman there called the guy nowhere to be found. Said I should come back. And Monday happened to be my journey. So I will call one woman there now to help me. I told her to help me. I have a sister there, second office, to help me track it so that if it's with the secretary, and I will know how to get it when we come back. I went there twice, so I couldn't get it. Group pair, okay. Group 3. Okay, it's still go. It's not yet. I'm sending it to you then. So in the it will upload in a moment. It's still going. That we put that. It's not refused to download. So it's refused to download. Don't know. It's maybe not. Clicking download, no, it's not. So?
Network is fine.
Okay, the table. Sir?
This afternoon.
Yes, this one. It's one already. I think they go by 1:30. They go by 1:30. You will still present the remaining renewable energy today. That one, the remaining one.
Depends on how hot you are.
Okay. What minute left? Are we done with this? Hmm? Ten? Group 3, you can check. Just I sent one to you. Group 2, you can check your group. So if you look at that one, group 2, it's about green sentences on, I think, what? Yes, on for battery application. That's cobalt vanadium. nanoparticle electrode for high energy lithium ion battery application. So it's a facile green synthesis procedure. So we can remove that vanadium and put another thing. Okay? So since we are writing a review, not this one is already done work. So you can remove the vanadium there. So let's check. So you can use this one as a template to search for another article related to this. So search for more work on this now. So let's see how we can modify the topic now. So search for, just use this title now to search for more. Let's see how we can modify it so that we can have our own topic. Then we now start to work on it. So you also work on that. Use this one to search for more. Then let's see how we can harmonize the whole thing together in a way that will be unique. So group 3, you can do the same thing. So that we can do that before.
Articles that actually have composites.
Yes, composite. Yo, no problem. The one that has composite, that would be good. So I think our time is up, right, for this one. 2 minutes. Okay, I think we are good to go. Yeah, we can change the compound. Check now. Instead of that vanadium now, check if we can have something related. So just modify that topic and check. Let's see if we can get similar thing that we can actually work on. So by the time you look at this, we can draw idea from this article, we'll now combine it to make our own unique. Just draw idea from about 2-3 articles. Then we'll combine it, we'll draw a particular topic. Facile subatomic synthesis, nickel ferrite nanoparticle for high performance supercomputer. Good, that's a very good word. So if we want to say facile subatomic synthesis, we may remove this one. This is a particular method now. So our own can be diverse method. Facile synthesis of, or we are working with what? Nickel ferrite nanoparticle, or we can form a composite of it. You can say nickel copper, which one was the nickel copper, zinc nanocomposites. So nickel, copper, zinc nanocomposites, ferrite nanocomposites for high performance supercapacitor application. So this one will come in as one of it. You are reviewing nickel, you are receiving copper, you are receiving zinc. We talk about everything on zinc, talk about everything on nickel, talk about everything on copper. So let's use this one now, combine it with that one, write it out, this one. So let's try and harmonize the topic now. Facile synthesis of nickel, copper, and ferrite. Yeah, you can copy it and be pasting it in your Word. Copy the paste it in your window. so that we look at 2 or 3, we harmonize it and to make it one topic. So in the next stage for this one, all we need to do, we are done with this one now, so we have to wash it. We wash it now with distilled water and what? And ethanol. After washing now, then we now prepare our surfactant. This one, while this one is still there, we can easily prepare these two. So we can easily prepare these two. So we can start with this one. While we are washing this one, then we prepare one of it, either the chitosan. We can prepare that one. We need just 50 ml at a very low temperature so that it can easily dissolve in the normally you dissolve it in the warm water. If you put it in the cold water, it will not be soluble. It's not readily soluble in cold water. Okay, so you dissolve it in warm water. So we'll prepare. Come, courage, come. So we'll use this. Let's use this one. What is remaining? So put okay. What we will do? Okay, rinse that one so that we can be using that one to fetch distilled water.
This one.
Bring that big one. Mm. I think we are done with this one, sir. This one can go. No, put it. Exactly. It's alright. So put small here to rinse it. Rinse it. Just put it in. So measure 50 ml. So we are going to dissolve each surfactant 50 ml. 50 ml. If you measure 50 ml, I think we are using 1 gram. If you check that in, 1 gram of 1 gram of this, 1 gram of this in 50 ml. Okay, put it. Yeah, I want to prepare this surfactant. So can remove this one. So the water will be warm before we put the something. So we'll on it. It has to be warm. Okay. It's already in 30, I think. Yes, it's to be a warm one for like 10 to 15 minutes before we put this something so that it can easily dissolve. So once the water is warm, then put the material. So it will be warm. It can easily dissolve in warm. So stir it very well. So once that one is cool, then we're now beginning to wash it. We first of all wash with so this one now you can see it. So there are different ways we can wash it. We can use centrifuge, load it in centrifuge, run it, it will wash it, decant it, put it again, run it to wash it, decant it. You can wash it like 3 times. At the same time, you can also use decantation method. You put it, you allow it to settle, you decant it, put it again, allow it to settle, you decant it. Okay? So these are various ways we can use to decant it. So what we will do now, we can have like 20 to 30 mil. Let's use 40 mil. So we'll put it. So allow it now. If you allow it for some while, you will see it will settle. Then we decant it. We'll repeat it like 4 times. So finally we wash it with ethanol. Then finally wash it with distilled water again. Okay, 3 times with distilled water, once with ethanol, finally with distilled water. So whatever we have as the residue is what we are going to use with this one. Okay. So you can see that it's already separating. So we can as well use the centrifuge tube to do that. So it's already warm. So let's prepare our 1 gram. So we'll just prepare the Kaito-san. Let me pick my cup. Hello? Yeah, Christian. Alpha.
I'm fine now.
Madam. Huh? Yes. It's not what? It's not what?
I said I was ready to document what because I wanted to tell you this morning. I noticed that all the work I did.
No, now, it was tracking. The person that reviewed it, track it. Did you click on the tracking? Have you corrected the one she tracked?
I've corrected the red system.
Yes, that's the tracking something. You have corrected those tracking points.
Yes. But because I was saving it.
It's not saving. So you cannot find it.
I think I did it in my desktop. And I went back. And I found out that the document is saved.
It did not save.
Yes, sir.
Save it again. Try and save it again. If you have corrected all the track point, then remove, take it to. No. It will be there now. Go back to where you corrected it. It will be there. Go back to that where you edited it. The correction should be there. You get it now? Just go there. So you can remove tracking before you forward it. Remove it from tracking after you have corrected it.
How would I remove it from tracking?
Yeah, if you go up, you will see tracking something there. Because after you have corrected it, it said effect all the corrections and remove from tracking. Just check all those review. I think under review. Click on that review, you see tracking and not tracking. Yeah. No, this one, we don't need to calculate this one. This one is already in gram already. So put the 1 gram. Stir it to dilute it. This is
Can they have their lunch now?
okay.
Stop the procedure.
No, it won't stop it. This is Kaito-san, the first one. Yeah, the Kaito-san. So that's what to measure here, 1 gram. So it's one of the first surfactant. Can it be? You can use it now. No, don't cover it. Yes, just leave it. So far, we are not performing multiple experiments.
So is it the one with 1 gram?
I'm coming. Let me pick my cup. Hello?
Hello, sir.
Yeah, Grace, how are you?
I think so.
Well done.
Sir, please, some of my classmates have said that 191 constraint. Is it it compulsory for them to do the exam on Friday?
They have not done what?
They misplaced the course rest for 191.
Let them print another one now.
Okay, they should print another one. Should they come and meet it to sample so they can go in like that?
They can go with it. I'm not even around now.
Okay,
Let them use it like that.
okay.
Mm.
Thank you, sir.
It's all right. That's step 4. See what we are doing now. This one. Chitosan and arginate preparation. 1 gram of chitosan and arginate will be dissolved in 50 ml of distilled water at 50 degrees Celsius, followed by stirring and heating at 4 gram per minute for 30 minutes.
So that means you're supposed to add the to it.
Yes, that's the it. It's on it.
What she said, are you going to combine that hydrogen and arginine?
No, separately.
Okay,
So I just use the same procedure.
okay.
The same procedure. We are going to prepare chitosan separate, arginate separate. Separate. So once we are done with this, they will now prepare, because this one we go for this. So we're going to repeat this one again for the second one. Are you getting it now? This one now, when we are done with washing, it will go with this. So we're going to prepare another sample again.
Plenty and divide.
It's possible.
Yeah, we should have done plenty. Yes.
So, other than that, we have like 2 of these. While you are running this, you can be running the other one. You get it now? Concurrently. So, how do you now divide it? That is the challenge now. When we get to liquid content. So, how do you now divide it that you make sure that you have equal content? So there's no way how would you measure it? Some of it will plaster with by the time you're using syringe, some will still attach to your syringe, some will attach to your.
Once you get your volume, you don't care what
No, you should care.
to the syringe.
No, you should care.
50 sir.
If you need 50 and almost 20 is attached to the syringe, so it will affect your concentration. It will affect your concentration. Though minute, but if it's minute, see where the result will show. By the time you characterize your SEM and your ADS is given to you, you will see the variation. In your ADS, it will be very obvious. You will see zinc giving you atomic weight of maybe this one now, 20 something gram. The other one will be giving you 10 gram. Reviewer will question you that, why is it so? That didn't you use the same quantity to prepare them? They begin to question you. But if the variation is not too more, very slightly, plus or minus 2, plus or minus, is understandable. But if it's too obvious, they will question you. So that's why precaution needs to be taken at times in some of these things. So it's better prepare it separately. Prepare this one, prepare that one. So that I think it's we stir it. Though we have been stirring it for 15 minutes, just another 15 minutes. No, warm the water first. You're supposed to warm it and stir it for it to just dissolve very well. Then we are still going to wash that one before we.
And we did not cover it.
No, because the reason that we are performing just one experiment, so I said we can leave it. Had it been that we are in a lab that is already congested, so it's better you cover your sample. Oh God, that experiment. Cover it because of that experiment.
Yes,
It's necessary. Go on break, please. Go and eat your food.